This question is to concern linear dependence between three given vectors, where one vector contains an unknown variable, b. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Copyright all rights reserved. Thank you so much. We're given three vectors. The first vector beta 1 is the column vector with entries 2, 1, 0, 1. The second vector beta 2 is the column vector with entries 1, 3, 2, 1. The third vector beta 3 is the column vector with entries 4, 7, b, 3. These three vectors are known to be linearly dependent. What is the value of b? There are four options. First step, that we construct the matrix. We place the three given vectors as columns of a matrix. So the first column is 2, 1, 0, 1. The second column is 1, 3, 2, 1. The third column is 4, 7, b, 3. Next step is to perform the first row operation. To get a simpler leading entry, we swap the first row and the second row. Now the top row begins with the number 1. After that swap, the matrix looks like this. First row 1, 3, 7. Second row 2, 1, 4. Third row 0, 2, b. Fourth row 1, 1, 3. Next, we eliminate the numbers below the first pivot. After elimination, the matrix becomes first row 1, 3, 7. Second row 0, negative 5, negative 10. Third row 0, 2, b. Fourth row 0, negative 2, negative 4. Then, next step, we simplify the second pivot. We divide the second row by negative 5 so that the pivot is equal to 1. After this step, the matrix is first row 1, 3, 7. Second row 0, 1, 2. Third row 0, 2, b. Fourth row 0, negative 2, negative 4. Next step, we continue elimination. We use the second pivot to eliminate the numbers in the third and fourth rows. After this elimination, the matrix becomes first row 1, 3, 7. Second row 0, 1, 2. Third row 0, 0, b minus 4. Fourth row 0, 0, 0. Next step, condition for linear dependence. The three vectors are linearly dependent when the last pivot disappears. This happens when b minus 4 equals 0. Therefore, b equals 4. Final answer. The correct choice is option C, which is 4. When checking for linear dependence, always form the matrix with the vectors as columns, reduce it step by step, and look for the parameter value that forces one pivot to vanish. That value is the condition for dependence. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Copyright all rights reserved. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.